Bismillahirrahmanirrahim. In this video, we'll be discussing question number 45 from the book about job examination written by Mr. Roni Pervez from Bangladesh. Now, this is the circuit that we'll be discussing. So two things you have to we just recall. First of all, when we replace a diode, we can replace it by a battery. And for silicon diode, we replace with the 0.7 volt battery. This line is actually for remembering that this is the negative side. So we put the negative of the battery up, and then this is the positive of the battery. But if the diode is ideal diode, then we do not draw a battery. We simply draw a line, a short circuit line, to represent a diode conducting. But in case of a Zener diode, there is slight difference. Now the Zener has some voltage written, like here it is written 5 volt. That means the Zener, when we operate it in the negative region, not the positive region, we don't operate Zener in the positive region, and we keep increasing the negative voltage, then it will break down. At some point, maximum current will start flow. That point is known as the breakdown voltage. So that is given here to be 5 volt in this case. So when this diode breaks down, then we replace it with a battery, but now the battery terminals are opposite of the diode. So this, the negative sign or the MOSFET will now represent the positive side, and the other side will represent negative side of the battery. This point you have to keep in mind. Now let's see the question, and it is similar to question 4.26 of SEDRA that I have made another video. I'll give a link of that. But this is very interesting, I find it. So let's see, find the expression for the output voltage V out in terms of the input voltage V in for the given circuit. Assume the forward voltage of the diodes are 0. That means these two diodes are to be considered as ideal diode. And VZ1, VZ2 of the Zener diodes is 5 volt. And as I was mentioning in example 4.2, we have done similar question, only instead of Zener, we had the two batteries. Anyway, now for evaluating this, we'll assume that there is a sinusoidal input signal. And first of all, if you look carefully, there could be 4 scenarios. The first scenario will be when V input is less than 5 volt here. Less than 5 volt means the circuit, first of all, it is positive. Therefore, this diode should conduct, this will not conduct. And because it is less than 5 volt, therefore, this will be off. The diode, the Zener will not break down. So there could be 4 scenarios like this. One is less than 5 volt. The other is when input is more than 5 volt. And similarly for the negative side. So we just draw a line to represent these 4 areas. This is the first one, second one, third one, and fourth one. So let's take the first one. When VV input is less than 5 volt, that means we are in this region. And because it is positive, therefore our circuit will become like this. This one will be reverse bias, so we're just eliminating this circuit. We take this circuit, and this 5 volt will not make the Zener forward bias, and therefore this will also not conduct. It will be in the reverse bias condition, and so we can say that it is, the diode is open circuit, and actually no current is flowing, therefore we eliminate this as well. So this will be our simple circuit. And from here you can see that the V out is equal to V in. So we write this relation for the first I1A. Now we come to 1B. When the voltage is greater than 5 volt, the circuit remains the same. Now at greater than 5 volt, this diode or the Zener will start conducting, and therefore we can replace. The Zener breakdown will take place, and the Zener diode Z1 can be replaced by a 5 volt battery. So our equivalent circuit would now look like this. The diode short circuited and Zener replaced by a 5 volt battery. And now we'll use the nodal analysis. For that, we have to mark the current directions. We can take any current direction, but keeping in mind that this voltage here, or VI, is now more than the V out, or more than the 5 volt. Therefore, this is at a higher potential. So the current will flow from higher potential to lower potential. So we'll take this current direction. And here it does not matter which direction we take, but we're just taking it that is going from up, 0 to up. Okay, now we'll write the equation. First one, current entering, current entering. First current, or the current entering left side, is VI minus V0 divided by R, plus this other current entering starting from 0, so 0 minus V0. And about this battery, should we write it plus or minus? So a simple technique, if you draw a small arrow from the positive side of the battery going outwards, and then you compare the main current and this current, if they are in the same direction, then the battery will be written as positive. So we'll write it positive 5. And now, since it is dividing by RR, so we just cancel R. So this will be the equation. And finally, solving this, we'll find V out to be VI plus 5 divided by 2. So this is part 2. Now we're coming to part 3. Similar logic, since it is in this region, and since it is negative, therefore this diode will conduct and this will be off. So this circuit will take, and because the input is less than the breakdown voltage, therefore this will behave like an open circuit. Zener will not allow current to flow. So open circuit, and again we can remove this. So this is the circuit. Here also V out is equal to V in. Okay, and finally, this relation, so we are somewhere here, and the same circuit, and now this voltage is more than the voltage here, or the more than the breakdown voltage. Therefore, now the Zener breakdown will take place, and the Zener diode Z2 can be replaced by a 5 volt battery. So circuit now will be like this. This is short circuit replacing by a battery. And remember the battery polarity you have to keep in mind. The mouse test is the positive. Okay. And again, we'll write the nodal equation. For that, remember this one is minus less than minus 5. Therefore, this is at the lower potential than the V0. So our arrow will now be like this, going from V0 to a lower potential, or going from minus 5 to less than minus 5, that is minus 6, minus 7. And this one also you can draw in any direction, but I'm just following the tradition that going down. And so the first one is VO minus VI divided by R, and here it is VO minus 0. And battery, again we draw a small arrow from the positive, it is going down, same direction as the main current, therefore the battery will be written as positive. So positive 5, and simplifying and further simplifying, we get this answer. So this is how you solve the question. These were the 4 scenarios that we obtained the answers. And if you want to write it neatly, this is how it can be written. So I hope you have been able to follow this. Please let me know through your comments. Thank you.